had a friend the other day who asked me a question about why it said that their internet order was from or coming December 31st, 1969. And, to me, being a tech person, I understand, C time, the way that Unix calculates time, and that somebody didn't sanitize their inputs, and so something returned -1, and but at the same time they asked me to try to Eli 5 it, and so here I am trying to do exactly that. So this is the error that they were presented with, right? That your next order is December 31st, 1969. And the reason that this would happen in a program is if there was some kind of a function call that was to compare two different dates, because the way that computers, web servers, whatever, like pretty much most computers these days calculate time is they measure the amount of seconds since the epoch, which was January 1st, 1970. The reasons for this are many, but basically Unix, the most common operating system in the world right now, was created by Bell Labs in 1969, and the guys figured, hey, we may as well just pick a time to start counting time, and that could be January 1st, 1970. So, let's interact. How do I interact with that? There we go. So, Unix time, it represents a point in time, the number of seconds that have elapsed since January 1st, 1970. And early Unix engineers picked that date arbitrarily because they needed to set a uniform date for the start of time. So in Unix time, the amount of seconds that have elapsed since January 1st, 1970 at midnight is 0. And you'll note that there's a negative number here to represent a time, in 1969, which is prior to the epoch, right? So in 2038, there's going to be a problem kind of like Y2K for, developers, engineers, programmers, whatever. Pretty sure it's mostly already figured out, but it's going to have to be a greater value than a 32-bit value. And that's something that's obviously easily overcome this day and age. Probably is going to make a whole bunch of developers busy, but, it's not really the end of the world, right? So let's look here with this Quora post, right? To explain how does a computer program actually work, right? How do lines of text tell a box of wires how to do anything? What about ones and zeros, right? So computers do operate in ones and zeros. A CPU is a processor that has a whole bunch of different transistors in it. Transistors and other logical transistor gates, and they implement very simple logical operators and, or, and not. So these values, or these logical constructs allow you to make comparisons between different values and compute a result, right? So, in a modern CPU, it's called microcode, where you say a machine code instruction for 76234, add together two numbers, which is an operation code 76, from memory in positions 2 and 3, and write the result into position 4. So this opcode right here, this machine language, it allows you to pull push, pop specific values that are numerical and therefore logical in nature. So you can make calculations based upon the values that are in individual memory registers. Memory is just a space for the processor to do its computing tasks, and everything is stored in binary. Conversion of binary to decimal kind of looks like this. So writing numbers in a decimal system, isn't the way the computers work. It's all done in binary. So we can represent this instruction to, add, accumulate, these two values and write to these two registers and write to this register. And something like this in, what would be like assembly or a low level language, right? But then in a programming language, it's more human readable. We could say something like, hey, I have this variable r that is 2.0, and I want to square the circle with this, and make these calculations, right? That is a higher level language, but it still is performing operations on registers, with and or not type values that are happening on a processor, right? And so when we look here, these are the values in the C programming language, which is, and this is out of the actual Linux source code that shows codes when a program is run versus errors that it could possibly throw, right? So in a program routine, function runs, it returns 0, right? And you see here, these are all positive numbers, right? But a very common a number for a function or a value to return inside a code is -1. Like, oops, I bailed out. This did not work right. Whatever I was trying to calculate or work out did not work out. And so in this one, if we're to interact, so in C, we have exit 0, exit success. Exit 0 means the program is terminated successfully. And then if we have an exit failure, it means that the program has terminated, abnormally, or there was some kind of an error or a fault condition. So exit 1 reports the abnormal termination of a program, right? So if we were to go to our own program here, I wrote this little program here, and what it does is it takes this variable a, and it makes a date value, something that would represent like the time that my dog food was ordered, right? And this is a get time value, which enables us to take that date and abstract it into a variable that has the time since the epoch in milliseconds, right? And then we have a function here, and the function takes C, it checks to see if C is undefined, and then it exits with a -1. Because if we have a function, the function takes a value, the value in this particular case is C, right? But we don't have C defined, it would exit with something like a -1 saying, oh, that's not a value that I have. Otherwise, it would return, C, whatever that value needs to be, right? I'm not actually assigning C a value. So if we have this function here to check dates, we have B minus C, right? Let's just say that C is the date that something was shipped, and B was the tracking number, or the time that something actually showed up on my doorstep, right? If we run this real quick, we'll see that, this little guy here printing the time, we are able to take this date, pop it into this variable. We are able to create the second variable with this get time to show us the amount of milliseconds right here. Or not milliseconds, or is it milliseconds? Shit. Yeah, it is. It's in milliseconds, not in seconds. So that's a lot of milliseconds since 1970. But here we have a uncaught reference. C is not defined. So because C is not defined, when we call that function, it exits with this process of -1, right? And so then if we go back to our CTime values and we look here, we see that, because January 1st, 1970 at midnight is 0, if we subtract even 1 a millisecond from that, or 1 second from that, we get December 31st, 1969. And so that is a little lesson in computer programs, how computer programs operate, and why you would get a silly error that is representative of a time that is way before the internet was even thought of, let alone, you ordered your stuff from Chewy.com. So it's really just that simple, that there was a function that whatever programmer had created was expecting a value, a really long value in milliseconds or seconds. And when that value did not return something, it's called sanity checking in programming, where we verify that an input is sanitized and meets with the specification of what we're expecting for a function. And so that's where, in order to avoid this sort of a thing, we have here in our function test, if our input is undefined, it exits. And what happened here is whomever works on the back-end code of Chewy.com did not sanitize their inputs. And they just returned C, or they just ran a function to check dates between B and C bailed out saying, oh, I'm not actually a value. So hopefully this was useful and instructive. It certainly was kind of fun to put together. So let me know if this is valuable. Thanks.